Hello, everybody. We're going to talk about part three of the Big Bang slideshow. We're going to talk today about identifying stars and what we can tell about other stars. So we know a lot about other stars around the universe, and how do we know so much? Well, we can tell certain things about them by looking at the light that they give off. Um, we can use the light to see stars. How do they identify different characteristics of those stars? By the colors of the lights and how we can see them. We know that obviously we can do some things with redshift to figure out how fast it's moving, but there's other things we can do too. We're not going to talk about all of them because some of it is a little bit more complicated probably than Science 9B wants to be, but we can talk about some of it. And we're going to start by talking about a spectrum. I think a lot of you have seen a spectrum of light. It comes from the rainbow, but there's also other forms of spectrums. It is a set that includes different versions of the same thing ordered in some way. So like for light, it can order by red to purple like a rainbow does, or it can do the whole spectrum that we'll talk about here in a second, but it also can be something that you see if you go to the doctor's office, like where are you feeling in your spectrum of moods right now, right? And there can be many different forms of this. When white light passes through a spectrum, or if sunlight passes through a raindrop, you can see a full spectrum of light all the way from red to purple. And that's how we get rainbows. So this is how it happens. This is a prism, obviously, but a raindrop acts similarly to this. This is the full spectrum. If you want to talk about it, we can see only the small part in the middle, where you can see the rainbow, but we also have X-rays, gamma rays, I should probably say them in order, gamma rays, X-rays, ultraviolet rays, infrared rays, microwave, and radio waves. It's all a spectrum. It's a larger spectrum. Our eyes, to be clear, this whole spectrum exists. Our eyes can only perceive part of it, a small part of it if you look. The atomic spectrum this is where we start to use it to identify different elements. If the electric current is passed through an element, it'll produce a color. This is how neon lights tend to work this way. So a white light is every color. Certain elements only produce part of that spectrum, okay, not the whole thing. Then we can talk about two things, emission versus absorption. This can be tricky, but it's really not more than just a vocabulary thing. So to emit something is to give it off, to push it off into other things. That's emit. So the emission spectrum, you're giving off light. And the absorption spectrum, if you can absorb something, you're taking it in, like a sponge will absorb water, things like that. So that's the absorption spectrum. So either you're giving it off or you're taking it in. And we'll see more why we talk about that here in a second. Okay, thank you. All right, so when you look at hydrogen, and I'm pointing at my screen like I always do. If you excite hydrogen, it's going to leave off these 5 bars of light. Okay, on the top you'll see it's all black, but it'll just relieve a couple of bars. Then that's the emission spectrum. So that's what hydrogen gives off. So if you want to look at the absorption spectrum, those same bars are going to be missing because hydrogen is using them. It's kind of confusing, but just bear with me. It's like a fingerprint because only hydrogen acts this way. So if you see this pattern, it's hydrogen. Similarly, if you have helium, it's going to have a different pattern, or boron or carbon or whatever, right? They all have different patterns. So you can tell if you see that pattern, you can be like, oh, that's hydrogen. And here we show some of the other wavelengths for hydrogen, sodium, helium, neon, mercury. You can see that they all are similar. They all have lines, but none of them are the same. Okay? Everything shines a different color, slightly. So, now that we went through all of that crazy stuff, how do we use this to identify what's in space? That was the whole point of this, right? Well, when light passes through an object, the atoms of the object absorb only certain wavelengths. So if you have a white light and it passes through a cloud, like in the diagram in the bottom, whether that cloud is hydrogen or helium or maybe both, the the light will come through and then hit a prism and spread, you're going to see what was in this cloud by looking at what's over here, these gaps, right? So if this cloud was made of hydrogen, you would see the pattern form here of hydrogen. If this cloud was made of sodium, gaseous sodium, if you had a white light, it would show the pattern for sodium. So if this was gone altogether, right? If this cloud was not there, white light would show the full spectrum, show all the rainbow. But because this cloud is taking away some of the light particles, the certain colors, the certain wavelengths that we saw back here, right? It's taking these away because it's absorbing them, then you get these gaps. So if we can look at these wavelengths that are missing, and we can use our deductive reasoning and say, okay, well, if this one's missing, it must be this, and if these are missing, it must be this. And there might be more than one. In fact, there usually is more than one, right? If we were to shine it through Earth's atmosphere, we would see lots of things missing because of all the different gases that we have, the nitrogens, the oxygens, the carbon dioxides, and well, carbon dioxide's not an element, but you could see all of those. Okay, great. That's the end of part 3. There is a video that I'm going to link. I didn't show it here, but there's a video that if you're a little lost on how the whole process works, it actually breaks down how you would do an absorption spectrum. It's not that long. It's like 2 minutes long. So if you want to watch that, I'm going to put it in the Schoology, so as a separate link. And then also we have the assignment from Mr. Henry that we're going to work on using this to fill out a worksheet. So thank you very much, and of slideshow and of screencast.